do it. Hey guys, welcome to the review session for the final exam. I'm glad that some of you can be here. Anyway, this will be a comprehensive review of the entire material. Well, I hope I can I can cover many things. Like I said, the final exam will be on Tuesday, and I would like to talk a bit about the final exam first. And let me just talk a bit about it. And then okay. Oops. All right. Okay. So the final exam, as I told you in the email.
I have noise canceling headphones, so if I need to block you out, all I have to do is just.
By the way, Robert.
Oh, sorry.
That's fine. Like I said, the final exam will be on December 8th, right? This Tuesday. So the final exam, this is very important. The final exam, it will be this Tuesday. December 8th. Make sure you mark this in your calendar. I'm sure you have other exams as well. December 8th. And like it is in the schedule, it is from 10:30 a.m. to, I think it was from 1 p.m., right? So 2 p.m., something like this, right? So 11 to 2 p.m., so you have 2.5 hours for this exam. The exam will be on Blackboard. So it will be conducted on Blackboard, just like the gateway exams, the two gateways, gateway 1 and 2. It will be on a similar fashion. There will be a total of 34 questions. Right? 34 questions there will be. By the way, those of you who logged in later on, please write your names on the chat so that I can see them. All right, so there will be 34 questions, and you will have something like this. These 34 questions will be defined in the following way. 10 questions will involve differentiability about derivatives of functions or something related. Another 10 questions will be about integration. So this will be important. Integration of functions. Basically, you'll have a bunch of integrals to compute. I will suggest you look at the last two videos, and you will see a bunch of methods there. And anyway, we'll do more examples today. And the rest of the questions will cover other sections. For example, just like in the same fashion as the exam from last year, we will compute, so other 14 questions. Wait, 24, 14, sorry, questions. We'll cover other qualitative properties, let me say, of differentiation and integration. And integration. This is important. It will be a multiple choice. Well, it is what it is. It's since it's online. It's not. I must confess, I'm not the biggest fan of this kind of exams. If I would do it my own way, I would have done it just like I did with the midterm. But anyway, this is the department's rule. I have to obey by it. It's a time test. You have 2.5 hours. Let me mention here, this is important. Make sure you log in. So this is important. Make sure you log in at 10:30 a.m. because it will be, in fact, I'll make it available from 10:30 to 2 p.m. So make sure you log in during that time. I don't know, I was thinking, but you know, I was thinking to make it available for the entire day, and you will have a time test. You can take it any time you want on Tuesday. But I want to stick to the rule. So the rule says pretty clear, the final exam should be between these two times, just like any other class. No proctored, but no. I don't know how to use those proctoring stuff, so it's fine. I'm sure you won't have time to, you have to be fast as well because there'll be a bunch of questions here. And the questions will be randomized, so. Anyway, about Gateway 2, we'll discuss it at the end. So what is the question about the Gateway 2? Somebody has
mentioned in the email that there will be 38 questions, but when we opened the exam, there
was only 10.
Yeah,
that's strange. Maybe I did not select the right option, but anyway, that's fine. It's my fault. So if you had only 10 questions, then it is what it is. Anyway, probably I messed up something there when I hope I'm not going to do it for. I hope I'll make sure
so the same happened in Gateway 1. You mentioned there were 25 questions.
For some in Gateway 1, those who took it afterwards, yeah, something like this happened. So I did not select something there. Anyway, so yeah, I'll make sure that you guys have 34 questions at the final exam. Qualitative properties means that something that's not quantitative. So I will not tell you. So basically applications of derivatives. So in other words, I mean here applications of derivatives. As you have seen in previous lectures, or integrals and so on. That's what I mean. For example, I give you a function, I would like you to draw the graph or tell me which one is the minimum, which one is the maximum, what kind of minimum, what kind of maximum is that? For example, I give you on what intervals is the function increasing, decreasing, what is the critical point, and so on. For example, on what intervals is the function concave up, concave down? What is the inflection point? And then maybe you'll tell me how to sketch the graph of a function, although I'm not sure if it's possible here, but probably it is just to put something on the graph. All right, so yes, multiple choice. Yes, exactly. 20 questions evaluating differentiation and integration. So yeah, the midterm exams grade will appear like tomorrow. You'll see them on Blackboard. All right. Any other questions you have about the exam? I'll send you more information about it tomorrow as well. Any other questions? No, you have to start at 10:30. I want all of you at 10:30 to be there. So just like the schedule, if you look in my syllabus, it says pretty clear. The final exam will be on Tuesday, December 8th, between 10:30 a.m. and 2 p.m. So I'll make it available during those times. So make sure you're there. All right. Any other questions? Yes, exactly. The exam will automatically close at 2. Yes, if you're not done with it, it will be closed at 2. So that you know. So make sure you finish it in time. Maybe I'll put it there like 2:05 so that you guys can have a final thing to select, whatever. But okay, I'll try to be flexible a bit. Maybe I'll add a couple of minutes, 10, 15 minutes, but after that, it's closed. That's it. And I want to make myself very clear, very, very clear. And I'll write it here. Only one attempt is allowed. So this is very important. It's not like the gateway where I gave you another opportunity to. That's it. Right? Any other questions? Well, if there are no questions on the chat, then I think we can get started. And I think we should do it. All right. Let's, and in fact, I have in front of me the exam from last year. And it's also on my website. And I would like to do a couple of problems here. So like I said, I don't want to dwell too much on computing integrals and differentiation. Well, I will try to, oh my, I'll try to do a couple of these problems, but like I said, I want to dwell more on other type of problems, more on applications of derivatives and integrals. All right, let's get started. So the first problem is the following. So it said, well, let me call it like this. In fact, no, let me write it. So yeah, it says that evaluate the derivative of each of the following functions. At the point x equals 1. This is important. Well, and choose the correct answer. Well, anyway, I'm not gonna say it's what are the choices. I'm just gonna give you directly. So the first function is f of x is x to the 4th plus x cubed plus x squared plus x plus 1. All right, the second will be f of x is e to the power 20 times x minus 1 Let's see another one. So I'm just going to be selective a bit. F of x is cosine squared of x minus 1 d. Let's see. Okay, let me look at this one. F of x is sine to the 4th of x minus 1 plus sine cubed of x minus 1 plus sine squared of x minus 1. And let's put another one, a. Let me look for something here. Okay, maybe this one, why not? F of x is x minus 1 times e to the x minus 1. All right, I want you to look at this, and I'd like to give you a couple of minutes to look at the problem, and then we'll discuss it. And then we can discuss. All right, let's see. So let's see the first one. Do you guys have any? So we have to evaluate the derivative. So what will be the derivative of the first one?
4x cubed plus 3x squared plus 2x plus 1.
Exactly, and when you evaluate it at 1, it will give you what?
10.
10, exactly, just like Matthew says. So this guy will be, as you can see, I have the sum of some functions there. So this would be 4x cubed plus 3x squared plus 2x plus 1. And now, so that's the derivative. So from here, clearly, when we plug in x equals 1, this will give us f prime of 1 will be 4 plus 3 plus 2 plus 1. So this is 10. And of course, we have 10 here, right? It's, yeah, we have it. Great. Now let's see the second one. So how we compute the derivative? F prime of x will be what? You see, we have the composition of two functions there. So it's e to the power u of x, where u of x is. So this would be like e. Okay, let me write it here. So remember that e to the power u of x prime. By the way, Matthew, I think your mic is on.
Oh, sorry.
So I would have the request, so anytime you want to answer a question, please turn on your mic. But once you you stop answering or you don't want to talk, please mute your mic, because otherwise it will get disturbed. It will disturb the lecture. Anyway, so keep in mind here that e to the u of x prime is e to the u of x times this guy here. And I think I stressed this in a previous lecture. We always have this guy here. So keep this in mind. So in our case, if you look at this, right? So f prime of x is nothing else. Let me write it in this way. So it's e to the power 2020 times x minus 1. And this guy, everything prime. So this guy will be e to the power 2020 times x minus 1 times 2020. Oh my, sorry about that. 2020 times x minus 1 prime. So this would be equal to e to the 2020 times x minus 1 times 2020. And now when we plug in, so it's f prime of 1 will give us what? Can you?
It'd be 2020.
Exactly, e to the power 0 times 2020, which is 2020, correct? Great. So we have, this is the answer, 2020. This is exactly the craziest year that I can remember. Anyway, all right, now let's see the third one. So C, again, here we have the composition of functions. So I want you to be very, very careful. So f prime of x, this is cosine squared of x minus 1 prime. So this guy, pay attention here. So you have a function inside. So the function here is the square function. So it's u squared of x, where u of x is cosine of, so let's write here. So u squared of x prime will be 2u of x times, again, is u prime of x. This is important here. So again, we have this, the chain rule, if you want, right? It's just a particular case of the chain rule for power functions. Okay. So in this case, in our case, this would be, would be what? It will be 2 cosine of x minus 1 times what? Times
Negative.
Okay, let's write it like this.
Okay.
So this would be
all of them.
the cosine of x minus 1 prime. So this would be 2 cosine of x minus 1 times negative, let me write it here, times negative sine of x minus 1. Ouch. Okay. I'll write it here, times negative sine of x minus 1. Okay, so clearly f prime of 1 will be, well, if we plug it in, so it will be 2 cosine of 0 sine of 0, but this one of them will be 0. Sine of 0 is 0, so this will be 0, and that's it. Okay, that's great. Now let's see D. So we have this function here. Look, again, we have, this will be interesting. So f of x is, so f prime of x will be sine to the power fourth of, what is it, of x minus 1 plus sine cubed of x minus 1 plus sine squared of x minus 1 prime. So this would be equal to sine to the fourth. So we apply the sum rule for the derivatives. So prime plus sine cubed of x minus 1 prime plus sine squared of x minus 1 prime. All right. So here we apply the sum rule, and now we would like to compute the derivative for each one of these functions. All right. So for the first one, again, as you can see, I have this time, and I want this, it's u to the power fourth of x prime. This is 4u cubed of x times, again, please do not forget about this u prime of x. Always, when you have the composition of functions, like you have the, right? So now in this case, now we apply for each one of them, not just 4, you also have 3, wherever. So in general, let me just say it, u to the power alpha of x prime. This would be alpha u to the power alpha minus 1 of x times u prime of x. This is important, right? Okay, and now let's apply this to our, so we will have what? We will have, in the first one will be 4 sine cubed of x minus 1 times the derivative of sine of x minus 1, right? Which will be cosine of, in fact, let me write it like this so that you can see. So sine of x minus 1 prime. Then the same thing goes for the second one, which will be 3 sine squared of x minus 1 times x minus 1, sine of x minus 1 prime, plus the last one, which will be 2 sine of x minus 1 times sine of x minus 1 prime. And all this mess here, so this would be equal to, okay, let me write it like this. So this will be equal to, if we, the sine of x minus 1. So here, keep in mind that sine of, okay, let me write it here.
Shouldn't it be cos x minus 1?
Yes, exactly. That's what I'm saying. Sine of x minus 1 prime will be cosine of x minus 1. All right. So I wrote it in this way so that I can emphasize the rule, so that you can guys see this guy here. All right. And now this will give us, so in fact, let me write it like this. So f prime of x will be, and now I'm just going to factor, so it will be 4 sine cubed of x minus 1 plus 3 sine squared of x minus 1 plus 2 sine of x minus 1, everything times cosine of x minus 1, right? And now, if we plug in x equals 1 in this, so this would be what? 4 sine of 0 plus 3 sine of 0 plus 2 sine of 0 times cosine of 0, which will give us what? Can you tell me?
0.
0. All this mess will give us 0, exactly. And this is how we compute the derivative of this. You see, it was a little bit more involved, but not that much. Now, let's go back to the last one, which was, so E. So the derivative here, f prime of x, will be what? Will be x minus 1 times e to the power x minus 1, everything prime. So what should we do here? Can you tell me?
We have to use a product rule, right?
Exactly, the product rule. So here we will use the product rule. Let me remind you the product rule. I'm reminding you here, which says that f times g prime, everything prime, this is f prime times g plus g prime times f. So this is the product rule. Keep this in mind. And in fact, I would like you to go over all these differentiation rules because this are important. If you don't know this, you're going to be in big trouble at the exam. So once we apply this, this would be, let me write it like, so you can take f to be x minus 1 and g to be e to the power x minus 1. So this would be x minus 1 prime times e to the x minus 1 plus e to the power x minus 1, everything prime times x minus 1. So now this would give us it's fine. I see some people have some, anyway. And this will give us what? So this would be 1 times e to the x minus 1 plus e to the x minus 1 will be what? Will be e to the x minus 1, exactly, right? And anyway, this will give us, if you, it will follow that f prime of 1 will be what? Can you tell me?
The answer would be 1.
1. It's e to the 0 plus 0, which is 1. Exactly. All right, guys. So this is problem 1. As you can see, I only did a couple of them. How many did I do? Like 5 of them, right? There are other 5s as well. You can compute the other problems that are in the exam from last year. There are find the derivative of ln of x, which I think you know, or the derivative of arcsine of x, which I think you know. Or another thing was to find the derivative of x cubed plus 1, everything over x plus 1, which you can decompose or whatever if you want to apply the quotient rule. In fact, let's do this one as well. Let me put here an f of x to be x cubed plus 1 over x plus 1. All right, let's do this one as well. So f of x, f prime of x will be x cubed plus 1 over x plus 1 prime, everything. So what would you suggest here?
That's just factoring.
Factoring. I think it's better to factor rather than applying the, what else can you do instead of factoring? What else can you do?
Division rule.
In quotient rule, right? So we can, let's do it the hard way. We can apply the quotient rule. But like I said, in this case, it's the hard way. So this is nothing else than just f over g prime, which is f prime times g minus g prime times f over g squared. So that's the quotient rule. Right. Anyway, let's apply this. So it will be x cubed. So we will take f to be x cubed plus 1 and g to be x plus 1. So this would be x cubed plus 1 prime times x plus 1 minus x plus 1 prime times x cubed plus 1. Everything over x plus 1, everything squared. And now let's do a bunch of computations here. So this would be equal, let me write it here, with 3x squared times x plus 1 minus x cubed plus 1. Everything over x plus 1 squared. And we keep going, and this would be, let's multiply here. So this would be 3x cubed plus 3x squared minus x cubed minus 1. Everything over x plus 1, everything squared. And this would be equal to 2x cubed plus 3x squared minus 1 everything over x plus 1 squared. And what can we do here? Can we factor something? Well, sure we do. Man, this is a little even more complicated, but anyway, we can break this guy. So we can write this 2x cubed plus 2x squared plus x squared minus 1, everything over x plus 1, everything squared. So this would be, so now we should group these guys in some way. So how should we do it? Well, maybe, okay, let's do it this way. So we can group the first two. So this would be 2x squared times x plus 1 plus x squared minus 1 over x plus 1 squared. And this would be equal to, you see how complicated this becomes. If you want, you can, okay, let's 2x squared times x plus 1 plus x squared minus 1. We can write this as x minus 1 plus times x plus 1. At least we know that. Everything over x plus 1 squared. So you see, sometimes when you do it, when you apply the quotient rule, you can get even more complicated than you think. So this would be, we factor x plus 1. So this is x plus 1 times 2x squared plus x minus 1. And this would be x plus 1 squared. This will go away, and this would be equal to 2x squared plus x minus 1, everything over x plus 1. And again, we can break this, we can do the same thing. So we can write x squared plus x squared minus 1 over x plus 1. And again, we can factor here. So we can say this is x times x plus 1 plus x squared minus 1, which is x minus 1 times x plus 1. Oh my. Everything over x plus 1. And we keep going. We can factor again x on x plus 1. And this would be x plus x minus 1, everything over x plus 1. But again, these two will just cancel here. So, and this will simplify, and this will be finally 2x minus 1. Phew, finally. You see, a little bit of hard work, but just like Matthew said, can we just like do it directly without doing this? Well, once we know this identity, so x squared plus 1 can be expressed as what? As x plus 1 times, so this is solution 2, x squared minus x plus 1. So use, and f prime of x will become, so let me write it again, x cubed plus 1 over x plus 1, everything prime. This would be, so once we factor this, or the top, once we factor it in this way, look, it is only x squared minus x plus 1 prime, and the derivative is 2x minus 1, one line, well, 2 lines once we know this identity. Again, you see, it's the same thing, right? You can do it you can do it both ways. The second solution has the advantage that we use that identity, so we can factor x cubed plus 1. But if, for example, if you don't know the formula, if you don't remember that factoring out, then you can do it the hard way, as you can see. So I did it both ways. All right, so these, you should expect something like this to compute 10 derivatives, though. And now I would like to veer towards the second problem. So let me see, how did I call this? So, okay, 1. Now let me do 2. Evaluate. Let me just, so evaluate the following integrals. Okay. And the first one is the integral from 0 to pi of sine of x dx. Then the integral from 0 to 1 of 3x squared plus 2x plus 1 dx. C. Okay, the integral from 0 to pi over 2 of secant squared of x. Wow, this exam was really a joke. Dx. Let me look for something else. The integral from pi over 6 to pi over 3 of 3 over pi dx. Okay, and let's do two more. The integral from 0 to 1 of 7x to the 6th over 1 plus x to the 7th dx. And the last one, the integral from 0 to 1 of 2x times e to the power x squared dx. Okay, guys, I want you to look at these problems and and we'll discuss them in a couple of minutes. So let's see. What do you think? Let's see. What about the first one? So the integral from 0 to pi of sine of x dx will be what?
I think it'll be negative cosine of x. plus c.
Exactly. Pay attention. The negative cosine of x, I said something in the video yesterday. So it's a definite integral. Pay attention here. See, you have the limits from 0 to pi, so it will be negative cosine of x from 0 to pi. So I said that if you go back to the video or you look at the notes, I said that the definite integral of a function will be a number. So keep that in mind. So this guy will be what? Will be
2.
negative. Exactly. So negative cosine of pi minus negative cosine of 0. So cosine of pi is -1, but with negative, so it will be 1 minus minus 1. So this would be 2. Indeed. By the way, I want to make a small comment here. Make sure you pay attention to the signs and everything, because it's a multiple choice, and so it will be a pity for you just to screw it up just like that. But anyway, let's see the second one. So the second one was this integral from 0 to 1 of, and you see here, I add up some functions. So this would be by applying the sum rule of the integral. So this would be the integral from 0 to 1 of 3x squared dx plus the integral from 0 to 1 of 2x dx plus the integral from 0 to 1 of 1 dx. And this would be equal to, well, we're going to take the constants now. So this would be 3, the integral from 0 to 1 of x dx, x squared dx plus 2 times the integral of x dx plus this integral, 1 dx. And now this would be equal to 3 times x cubed over 3. So the antiderivative of x squared is x cubed over 3 from 0 to 1 plus 2 times x squared over 2 from 0 to 1 plus x from 0 to 1. Again, this would be a number. And this would be what? This would be
3.
3, right? Okay, I'm going to leave this to you to figure out. So it's 3, correct. That's good. Now let's see the third one. So the third one was what? The integral from 0 to pi over 4 of secant squared of x dx. Can you tell me what is the antiderivative of secant squared of x?
Negative tan x.
Is, pay attention. Not quite.
Tan x.
Is exactly the tan of x, so it's tangent of x. So this would be tangent of x from 0 to pi over 4. And this would give us what? Tangent of pi over 4 minus tangent of 0. So this is 1 minus 0, which is 1. All right, let's see, d. So the integral from pi over 6 to pi over 3, and I would like you to pay attention here, of 3 over pi dx. What is this equal to? Okay, but first, can you tell me what happens to the function inside? What kind of function is that?
That's not a function, that's a number.
So this is a constant. So this guy here is a constant. So don't get distracted. You don't have anything with x there. It's just 3 over pi. Great. So I'll take this outside the integral, so it's 3 over pi times the integral from pi over 6 to pi over 3 of 1 dx, which would give us what? This will give us 3 over pi times x from pi over 6 to pi over 3, which will be 3 over pi times pi over 3 minus pi over 6. And all this thing here will give us what? Can you tell me?
1 by 2.
Which is what?
1 by 2.
1 by 2?
Yeah.
No.
1 minus 1 by 2.
It's 3 over pi. And this guy here is what? What is pi over 3 minus pi over 6? Is what? Is?
I opened the brackets and that's how I.
It's pi over 3. So this is 1. Is it clear, Tejas?
No.
Well,
So it's supposed to be 3
So
pi into pi by 3 minus
this is
3
pi
upon
over, this is, ouch. This guy here is what? This is, the common denominator is 6. So it will be 2 pi minus pi, which is, oh, wait, it's pi over 6. Sorry about that.
Okay.
Correct. You're right. Yes, it's pi over 6, correct. Yeah, my bad. Right. So this would be equal to 1 over 2, correct. Yep. All right. Let's see. E is this integral. So E is the integral of 7x to the 6th over 1 plus x to the 7th dx. Okay, how would you solve this?
You use U substitution.
We use U substitution. And what kind of U substitution would you use here?
Make U equal 1 plus x to the power of 7.
Correct, right? But all right. By the way, I would like some others also to be active, if you don't mind, not just Matthew and Tejas. So from here, so make this U substitution. And this will imply that du is d of 1 plus x to the 7th. And this guy is what? 7x to the 6th dx. Oh, okay. Wow. Look at. So this integral, you see, this is great. So let me write it again. So du is 7x to the 6th dx. So let's keep this in mind. And now this integral, so the integral of, and I'm going to write it in this way, 1 over 1 plus x to the 7th times 7x to the 6th dx. So that you can see, this guy here is u. This guy here, all of it is du. You see, because du is 7x to the 6th dx. So, and by the way, we forgot about the bounds, so we should be careful. So before we go into this, we should be careful about the bounds. You see, it's a definite integral. And now let's see, when x equals 0, u will be what? Can you tell me?
1.
1. When x equals 1, u will be what?
2.
2, correct. So now the integral will become the following. So the integral from 0 to 1 of, again, let me write it in this way, 1 plus x to the 7th times 7x to the 6 dx. So just like I said, this is u, this is du. So this would be, now we'll transform everything. So change the limits, so it will be from the integral from 1 to 2 of 1 over u du. And do you know what is the antiderivative of 1 over u? So do you know what function, the derivative of of what function will give us 1 over u?
The natural
That's the
log
log.
of the absolute value of
Exactly.
u.
The natural log of the absolute value of u from 1 to 2, which will be nothing else than what? Well, if we will be what? ln of 2 minus ln of 1. Or we can go back to the substitution if you want, but it doesn't really matter because it will be just a value. So this is ln of 1 is 0, so this is ln of 2. So that's the final value. Is it clear for everybody how we solve this particular? Yes, we'll go there as well. Once we finish this exercise, we'll do more problems with limits, functions, continuity, especially applications of L'Hopital rule. So I have this in mind. But still, we still have 1 hour to go. So, all right. So once again, is this clear for everybody? All right, that's good.
Why did you do the second integral again? Like for the 1 and 2?
Because I changed the bounds, you see? Initial bounds, you see the initial integral has, I changed the variable. The initial integral is everything in terms of x, correct?
Okay. Oh, you did. Okay, okay.
And now when I change the variable in terms of u, that's why we call it the u sub. So everything that's with x will turn into something that will be with u. And now you have to know that this is when x is 0 and x is 1. And this is when u is 1 and u is 2.
Okay, bad. Okay, thank you.
Sometimes when we write this integral from 0 to 1, you understand that when x goes from 0 to 1, and the second one when u goes from 0 to 1.
Okay,
right.
thank you.
Sure. Any other questions? All right. Well, if there are no questions, then I assume that everything is clear. It's great. All right. All right. There is one more, I think. F. Oh, okay. Again, F. All right. Let's look at this integral. So this integral was 2x times e to the x squared dx. Again, can you tell me what should we do in this integral?
U substitution.
The u substitution. What kind of u substitution? So we let u to be which one?
X squared.
X squared.
Like on the
circle. Yes, sir.
Okay.
And so.
All right. So we let u equals x squared. So from here, du will be dx squared, which will be equivalent with du equals dx squared is 2x dx. Okay, so we have this. That's great. As you can see, we have inside the integral 2x dx. But anyway, nevertheless, let's now take care of the bounds. So when x equals 0, u will be what? 0.
0.
And when x equals 1, u will be what?
Yeah. I mean.
1.
1, correct. So now our integral, the integral from 0 to 1 of 2x e to the x squared dx, this would be, now we're going to change everything with variable u. So let me just rewrite this a bit so that you can see it's e to the x squared times 2x dx. And now we're going to change everything to variable u. It's still again 0 to 1. Pay attention here. When x is 0, u is 0, and when x is 1, u is 1. So I have this 0, 1. So the limits of the integral are the same. And I'll have e to the u, right, times this guy here is du, and this guy here is e to the u. It's e to the u du. So this will be, what is the antiderivative of e to the power u? Is what?
E to the power u.
E to the power u, correct.
Actually,
From
no.
0 to 1, which is e to the power 1 minus e to the 0, so which is e minus 1. And that's the answer, final answer. All right. So this sums up everything we need to know about derivatives, how to compute derivatives. There's more, these are what we call the more quantitative properties of derivatives in integrals, so how to compute them. There were some other questions here in a similar fashion, but anyway, I'm not gonna. All right, now I'd like to do something about finding some limits. So the third problem I have in mind, and again, this was a problem from last year, which says the following. It says evaluate the following limits if they exist. The first one was the limit as x approaches 1 of x to the power 10 minus 1 over x minus 1. And the second one was the limit as x approaches infinity of x to the power 1 over x. All right. I want you to think of this problem for a bit, and then we'll discuss. We'll discuss it. All right, let's see. So what ideas do you have? I want to hear somebody else as well. I mean, you have the exam, not me. So what about the first one? What kind of indeterminate do we have? If we plug in x equals 1, so as x approaches 1, what kind of indeterminate do we have?
It would be undefined.
But what kind of undefined? So
Oh, it'd be 0 over 0.
0 over 0, right? So if we plug it in, so this is 0 over 0. So what did we say when we have 0 over 0?
L'Hopital's rule.
Exactly, we can apply L'Hopital's rule. So this would be, so the limit as x approaches 1 of x to the power 10 minus 1 over x minus 1 is here, and we say LH, so we apply the L'Hopital rule because the indeterminate is 0 over 0. So this would be the limit as x approaches 1 of x to the power 10 minus 1 prime over x minus 1 prime. But this would give us what? This would give us the limit as x approaches 1 or of 10x to the power 9 over 1. And if we plug it in, this would give us 10. That's it. You see how easy this is using L'Hopital rule? All right, there you can also factor x to the 10 minus 1. Yes, it's much better than factoring because, okay, let me write it with factoring. Also, we have that x to the power 10 minus 1 is nothing else than just x minus 1 times x to the power 9 plus x to the power 8, and we keep going, plus x plus 1, right? So we have this. And now this will imply that, and this gives us that the limit as x approaches 1 of x to the power 10 minus 1 over x minus 1 is the limit as x approaches 1 of, now I can write this here, x minus 1 times x to the 9 right? This will cancel, so this would be nothing else than just the limit as x approaches 1 of x to the 9th plus x to the 8th plus all the way plus x plus 1. And now if we plug in x equals 1, we have 1 plus 1 plus 1 plus 1. How many times? 10 times, right? So this will be 10. So you see it's the same thing. But provided that you know this, that you remember this. If not, then your only hope in this case will be L'Hopital rule. Okay, now let's see the second one. You see the second one. I want you to tell me, just look at it. What kind of indeterminate do we have? If we pass the limit as x approaches infinity, we have what?
You'll have infinity.
Say that again.
Won't it be infinity?
Look, it's infinity to the power 0.
So it equal 1.
Nope, nope, nope. It's not 1. It's not 1. It's an indeterminate. Pay attention. They say the limit will be 1. Well, in this case, you're right. The limit will be 1 indeed, but infinity to the power 0 is not 1. Is it indeterminate? Pay attention to that. Any number to the power 0 will be 1, but provided that that number is finite. So keep that in mind. Okay. So what can we do? Can we somehow do something here? So let me write it again. So it's the lim as x approaches infinity of x to the power 1 over x. So what would you say about this? What would you do?
Maybe we can put x to the power 1 by x in the denominator by
By what? By doing what?
by 1 upon x to the power minus 1 by x.
So what? It's still the same thing. No, there is something that we do here. When we have a function to power another function.
Be e to the ln of x.
Exactly. We can do this, or we can take the log. So pay attention here. We're going to do it both ways, although I'll tell you from the beginning they're the same. So let me do it just like Robert says. We'll write this as limit as x approaches infinity of e to the power ln of x to the 1 to the power 1 over x. You see? I can always do this trick. And now this would be equal to the limit as x approaches infinity of e to ln of x over x. And now e will commute with the limit, so this will be equal to e to the limit as x approaches infinity of ln of x over x. And now I need to take care of this guy. So now we compute the limit as x approaches infinity of ln of x over x. What can you tell me about this? So what kind of indeterminate do we have? Can you tell me? If we pass to the limit?
It's infinity over infinity.
Infinity over infinity, correct. And what can we do in this case? Who comes to rescue us?
L'Hopital's rule.
Exactly. L'Hopital comes into the rescue. So this would be the limit as x approaches infinity of ln of x prime, everything over x prime. So this would be, this is the limit of x approaches infinity. So ln of x prime is 1 over x, everything over 1. And this guy will give us what? Can you tell me?
1 over infinity.
Which is?
0.
0.
Exactly. Are we done? Whoa, not yet. This is not the final answer. The final answer will be, so this is e to the power 0, which is 1. So the limit as x approaches infinity of x to the 1 over x is e to the 0, which is 1. Great. All right. You see, we apply this trick here, e to the not to the power ln of e of something, right? Is that something? All right. But what if we don't know this trick? Is there another way to do this problem? What do you think? Which is equivalent with this one, but it's more like straightforward. When you have power to the power, when you have a function power to another function, what is the most convenient thing for you to do?
Chain rule? No.
To take what? To take the log, right? So we can take the log. So another way, or an alternative way. An alternative solution for the second one. So let's see. So we have that we take the log, so ln of the limit as x approaches infinity of x to the power 1 over x is, we know ln commutes with the limit, so this would be the limit as x approaches infinity of ln of x to the power 1 over x. So this would be the lim as x approaches infinity of ln of x over x. But we have seen that, right, that this limit is 0, right? By L'Hopital rule, by previous considerations, right? Right, you see it here above, we did this. So the ln of the limit is 0, So this means that the limit as x approaches infinity of x to the power 1 over x is e to the 0, which is 1, and that's it. Anyway, it's pretty similar. They're very equivalent, I would say. Is this problem clear for everybody? Any questions regarding this? I don't know, I'm feeling like I'm talking to a few people, so I want to hear some others as well. So what do you think? Is it clear for everybody?
Yes, it makes sense.
Okay, that's good.
Yeah, it's good.
Now, since I see some of you, okay, let's do more examples with L'Hopital rule. So more examples with L'Hopital rule. Is that okay? Okay, let me do more examples. And probably you would like to see some not very easy examples, or maybe some of them. Just give me 1 second. Oh man. Oh wait, just a second. Okay, I think I found some other problems using L'Hopital rule. Okay. All right, give me 1 second. Okay, let me see. So let's see, 4. Evaluate the following limits. The first one that I have in mind is so the limit as x approaches 0 of 1 minus cosine of x, everything over x squared. And the second one is the limit as x approaches 0 plus, so 0 from the right, of x to the power, pay attention here, negative ln of x. So it will be something similar. All right. So I want you to think of these two problems for a bit, these two limits. All right, let's see. So what would you do?
First, I would see if it equals 0 over 0.
Exactly. Well, okay, let's see the first one. What kind of indeterminate do we have?
We have 0 over 0.
0 over 0, correct. So we're in the position to apply L'Hopital rule, right? So this would give us the limit as x approaches 0 of 1 minus cosine of x, everything prime, everything over x squared prime, right? And this would give us the limit as x approaches 0 of what?
It'd give us sine of x over 2x.
Sine of x over 2x. So which is equal to 1/2 if you take it out, times the limit as x approaches of 0, sorry, of sine of x over x. But what do you know about this guy? This limit is what?
0
over 0.
Okay, we can still apply L'Hopital rule again, but you know that this is one. I have already done this in one of the lectures. So the limit is 1/2, right? Okay. Now, let's see the second one. The second one, it's like I said, it's a little bit more complicated. As you can see, in a similar fashion with, if you go back to problem 3, look at this. You see the second part is pretty similar to this one, right? So maybe we should do the same. Why not? So, but first, let's analyze it a bit. So as let me write it again. So it's the lim as x approaches 0 plus, so 0 from the right, of x to the power negative ln of x. Right? So what can we say? So as x approaches 0 plus, what can we say? Negative ln of x will converge to what? This will diverge basically to infinity, right? So the result is something which is very small to something very large. So it can be, it's indefinite. So what we do is the following, and pay attention here. So we have that. So we write x to the power ln of x, and we're going to write in the following way: is e to the ln of x, everything to the power negative ln of x. You see, I write this x as e to the ln of x, and this would give us e to the negative ln of ln of x squared. Let's see. So I have so I see there is a question here. Which Vedant, which problem are you talking about? What do you mean the first sum? The first problem from this, okay, let me see. Ouch. You mean the very, very first problem, this problem here? That's what you're asking? Anyway, you can ask at the end. Oh, okay, let's not lose any time. And then if you have questions about previous problems, you can ask them at the end. We can talk about it. All right. All right, so we can write this in this way. The one above this. You mean the one with 1 minus cosine of x, or everything over x squared?
Yeah, that one.
This one. So
Yeah,
what kind of method do you have? With sums, you say? Probably you say it with Taylor sums. That's what you mean, right?
I don't know Taylor sums, but the one which I saw, one should be written as sine square x by 2 plus cos square x by 2. And cos x should be written as cos square x by 2 minus sine square x by 2. So the total sum comes out to be 2 sine square x by 2 upon x square.
So basically you just apply identities. Yes, you can do it.
Yeah, trigonometric identities.
Trigonometric identities. Yeah, because I was a bit when you and when you say the first sum, I was like, So the first question you mean?
No. So if this was a written paper, would this method be accepted?
Yeah, because I don't care as long as you know it's a multiple choice. I don't care how you do it.
No. Okay, cool.
So it's a multiple choice. And either way, if for example, if the exam was like the midterm, I don't care the way you do it, as long as you do it. I will never tell you use this method, use this thing, do it like I do like I did it. I don't care. As long for me, it's actually I will be happy if you know other methods which are outside this class. I'll be wow. These guys are interested in doing more outside of this class. I'll be extremely happy to see something like this. Anyway, all right, let's go back to this problem. So as you can see, so I will use the same trick. So I will have that x to the power negative ln of x is e to the negative ln of x squared. And now what I'm going to do is the following. So the limit as x approaches 0 from the right of x to the power ln of x will be e to the negative ln of x squared. And now we should be careful here because this guy, can you tell me this guy is what? Maybe we should do a change of variable so that you can see it better. So maybe okay. So now, well, we'll do a u sub. So let me take u to be negative ln of x squared. As x approaches 0 plus, u will approach what? Can you tell me? And be careful here.
Maybe 0?
Nope, ln of 0. No, pay attention. Is ln of 0.
It's not defined, right? ln of 0 is not possible.
Yes, but as x approaches 0, pay attention.
The ln of infinity?
Exactly, it will be infinity squared, which is infinity, but you have a negative there, so it will be negative infinity, right? So this would be the limit as u approaches negative infinity of e to the power u. Now, can you tell me what this is? What is this limit as u approaches negative infinity? Pay attention.
So as u approaches negative infinity, that would be 1 over e infinity. So
I mean, yeah,
maybe that would equal 0.
0, correct. So the limit will be 0, right? So finally, the limit as x approaches 0 plus of x to the ln of x is what? Is 0, right? That's it. That's the final answer. You see, it was a bit tricky. So you need to look at it very, very, very carefully. All right. So I think, yeah, I think this is enough with L'Hopital rule. I want to veer towards something else as well. Maybe I should do some related rates. So this was problem number 4. Now let's do problem number 5. And I think I have something else here because I want to do some min, max, and stuff like that as well. All right, let's do this problem. So find the absolute minimum and the absolute maximum value of the function, and I'd like you to pay attention of this function, of the function f of x equals x squared minus 1 everything cubed, and on the interval -1, 2. Okay, think about it for a couple of minutes. Right, let's see. So what should we do here?
We differentiate the function.
Exactly. So first of all, we need to find, so first off, we need to find the critical points. That's very important, right? The critical points. So first we need to, the derivative f prime of x will be, and pay attention here because it's, so what is the derivative of this? Can you tell me? So you have the u cubed, let me remind you, is u cubed of x prime, which is 3u squared of x times u prime of x. Keep that in mind, right? We have the chain rule. So this would be, this will give us what? Can you tell me? So the derivative will be what?
It'd be 6x times.
Pay attention. Well, first of all, let's write, yes, it will be that. It's 3x squared minus 1, correct?
Whole square.
Times x squared minus 1 prime. And this would give us 3x squared minus 1 squared times 2x. And this would give us what? 6x times x squared minus 1 squared. So that's the derivative. So what are the critical numbers? So critical numbers are what?
It'd be 0 and 1.
Will be 0, pay attention a bit.
0 plus minus 1.
0 and plus minus 1. So x equals 0, x equals -1, and x equals 1. So these are the critical numbers.
Oh, that's right.
Because x squared, you see this guy here, you can write it as 6 times x. This is x minus 1 times x plus 1. Everything squared, each one, if you want. You see we have 3 zeros. Okay, great. And now what else? Since we're asked to look at the statement, I'm asked to find the absolute minimum and the absolute maximum values of this function, and pay attention, I'm asked to do it on this interval. So what else should I evaluate in this case?
2.
To what?
We also need to evaluate the second derivative.
Nope. Pay attention. I'm not asking about anything about second derivative. I'm asking, oh, well, if you want to say that
You
again.
put the values of x into the original function.
Which values? What values?
0, -1, 1.
Exactly. Wait. And okay, we need to evaluate also the endpoints. That's what I wanted to. Which are what? -1 and 2. So we need to evaluate the function of these. So now evaluate f at the critical numbers and endpoints. Right, that's what we need to do. So once we do this, we have f of -1 will be what? 0. F of 0 would be, just look at the function, -1. F of 1 is 0. And f of what? What else do we have? F of 2 will be what? Can you tell me? It's 27.
Oh, yeah.
So which one is the minimum? Which one is the maximum?
0 is the minimum and 2 is the maximum.
So 0 is the minimum and 2 is the maximum. So 0 is the absolute minimum. Well, wait, no, pay attention. I want you to pay attention here. I didn't say at what points do we get the minimum and the maximum. So which one is the minimum, which one is the maximum value?
-1 and 27.
Exactly. So -1. Okay, I'm going to write it like this. And 27. So this is the absolute minimum. And this guy is the absolute maximum. That's it. Right? This is how it's pretty straightforward how to do this kind of problem. You just take the derivative, you find the critical numbers, you evaluate the f at critical numbers, and since we're asked to find this on an interval, you also evaluate the function at the endpoints of the interval, and that's it. You see which one is the biggest, which one is the smallest, and that's your min, that's your max, whatever. All right. In the remaining time, I'd like to do another problem from the exam last year, and perhaps if I have some other time, I'll do it. And I have maybe an application. So the problem was the following. So let f of x be this function x times ln of x, where x is a real number. All right. So what we need to do is the following. First, what is the domain of this function? Right? Second, compute the first and second derivative. Now, the third part. So this was the last question on the final exam, the most difficult, as they say. What else is here? Draw a chart for the function f. Indicating the values x corresponding to critical points and inflection points whatever the case. Wow, that's pretty long. Wherever the case. All right. What else? So indicate the intervals where f is increasing, decreasing, concave up, concave down. And now finally, well, sketch the graph of f. Okay, all right. So that's the statement of the problem, pretty long, but let's see. So first we need to find the domain. What is the domain of this? Can you tell me?
0 to infinity.
0 to infinity. So the domain x will be 0 to infinity, right? Because the ln of x is defined for x positive. So this is the only thing, the only interval that we can talk about, 0 infinity. Okay, great. Now let's compute the first derivative. F prime of x is what? Is we apply here the product rule. So it's x ln of x prime. So by the product rule here, this would give us x prime ln of x plus x ln of x prime, which would be ln of x plus x times 1 over x, which is ln of x plus 1. So that's the first derivative. Now the second derivative will be nothing else than just the derivative of the first derivative, or if you want, is ln of x plus 1 everything prime, which will be 1 over x. All right. So now we have the domain, we have the first derivative, we have the second derivative. Great. Now we want to draw a chart for function f where we will indicate where the function is increasing, decreasing, and so on. Okay, let's draw the chart. And on this chart, we'll identify basically everything you need to know about the function. So here we have x, here we have f of x. So I will advise you to do the same thing when you have something similar, because on the chart you will see everything. So here x will go from 0 to infinity, open interval. Then we will see some values. So f prime of x, and let's say f second prime of x, second derivative. And now let's put all the information that we know. All right, for what values of x is the second derivative? 0, for example.
Infinity.
Pay attention, please. When is this guy 0?
When x equals e.
1 over e, right?
Yes, sir.
So at 1 over e, so we put here 1 over e. All right. Okay, great. But we also have, this is when the derivative is 0. So you will put here f prime of x equals 0, right? Now, on the other hand, we'll also put here a 0, but it will not touch 0. It will only be the limit as x approaches 0. We'll be very careful with that. By the way, limit as x approaches 0 plus of x ln of x will be 0. And I'll leave this to you as an exercise to prove it. Because the function at 0, but it won't be 0. Plug in x equals 0, you'll take the limit because the function is not defined at 0. So just apply, and I'll leave this to you as an exercise, apply L'Hopital rule. Of course, it's infinity times 0 here, but you have to make it look like a L'Hopital rule. It's actually a good, okay, let me just, so you can write this as the limit as x approaches 0 plus of ln of x, everything 1 over x, and then apply L'Hopital rule. So write this as this and apply L'Hopital rule. And I'll leave this to you as an exercise to continue it and finish it off. Apply L'Hopital rule. Anyway, so at 0 is 0, right? But this is the limit. Let's see, what else do we have? For what, so for also at 1, when x equals 1, the function will be 0 as well, right? And now let's see. So the derivative will be 0 only at 1e. Let's see, what can you tell me? On the interval 0, 1 over e, how is the function f? Is it negative? Is it positive? In fact, let's look at the derivative. On the interval 0, 1 over e, is the derivative, the first derivative, is it 0 or not? So just look who the first derivative is and the second derivative is. Look at these two functions.
Time, but every
What was the
day,
question again?
So
like every time.
how is the first derivative on the interval 0, 1 over e? Is it positive? Is it negative? So for x less than 1 over e. So the derivative will be negative, right? And then for x greater than 1 over 8 will be positive. So you put plus here. All right. Now let's see the second derivative. What do you think about the second derivative? For x positive, it will be positive. So I'll have only plus here. So the function will be concave up. So I don't have any problems whatsoever in this case. Now let's go back to our function. How do you think the function is? The first derivative on the interval 0, 1 over e will be what? Will be decreasing. So since the first derivative is negative, the function will be decreasing, and then it will be increasing for x greater than 1 over e. All right, so we have a function here that is decreasing on the interval 0, 1 over e, increasing from on the interval 1 over e plus infinity. And this function is concave up all the way on the entire interval. So let's draw the graph. I think based on this information, we can do it. So let's do it. So the graph would look like this. So at 0, it will be 0, but as you can see, it doesn't touch the point. So I'll put here something like this. So here will be the point 1 over e, which will be obtained for will be obtained at negative 1 over e. So right, this will be the point. So the function will go like this. So it will be decreasing. Sorry about that. It will go something like this. Right? And it will go like this. So here will be the point, let's say 1. So this is the graph of the function. As you can see, and it keeps going. It's not defined at 0, and this is how the graph is. So it decreases on the interval 0, 1 over e, but it still holds the water, as you can see. So it's concave up all the way. And that was the most difficult problem in the exam last year. Okay, my intention was, I think I'm going to stop here. Well, this sums up the review session for the exam. Well, let me stop the recording.